Welcome. Today's lesson is entitled Finding Models for Sinusoidal Graphs and Data. For pre-calculus, this represents day 1 of a 2-day lesson. For advanced algebra 2, this represents sort of a one and done situation. We'll go ahead and develop a few examples to get a couple ideas going, and then finish up with a nice application with sinusoidal modeling. So grab a graphing calculator if you would. What I'd like to do before jumping into example 1 is just to take a quick peek at your basic sine and cosine functions, just to get a look at those and see what we want to do with them. So let's go ahead and grab the calculator and go to the y equals for me, and just type in y equals sine of x, and let's hit zoom and number 7 there, and that should look very familiar. And just kind of keep an eye on that sinusoidal wave, especially coming from the y-intercept. You notice it kind of starts in the midline, and then it goes up, comes back down, and after the end of the cycle, it ends at the midline. So midline to midline in terms of that primary cycle. Great. Go back to the y equals if you would, and just very quickly, let's just type in y equals cosine of x. Obviously, these graphs are interchangeable, but if we play our cards right on these examples, we should not have to deal with any phase shifts or anything like that. So look at cosine if you would, very similar in nature. There's your sinusoidal wave, but in this case it looks like it kind of starts at a maximum, goes down, and then comes up, and it goes from maximum to maximum on that primary cycle. All right, good. Keep those very quick conclusions in mind if you would, because we're going to do examples 1, 2, and 3 here using those ideas. Okay. Well, guys, stare at the graph a little bit for example 1, and let's answer part A. It says, which is better, sine or cosine? Again, either one would work, but if we do things correctly, if we answer this question, I think, correctly, we can avoid a lot of issues with a potential phase shift. Okay, so which is better here, sine or cosine? And look at it from the y-intercept. In this case, we're starting at the midline, going up, coming back down, going up again. And if you look, it's kind of a midline to midline situation directly. And which function does that match in particular? Sine. Great. So that's the conclusion we drew already. And now what we can do is avoid having any type of phase shift. So you'll notice on the paper there's no C value. So I've got A and B and D. C is going to be 0 because we chose correctly. Now I happen to do the midline first here. So I'm going to go ahead and do the midline on the board and then write that in. But it looks like the midline right in between the max and the min seems to be right there. And so from my perspective, that horizontal line looks to be y equals -1. So let's go ahead and fill that in down here. So remember the connection, of course. Midline is really what produces the D value. So I know when we write this function, we're going to have a -1 on the back. Perfect. Second thing I do then, once that midline is drawn in, I go up and take care of the amplitude. And so just a matter of counting at this point. How far is it from the midline to the max, or midline to the min? And it looks like 1, 2 units on up. So amplitude is 2. Remember the connection between the amplitude and the A value, and so A is going to be 2 as well. Super. Now everyone, let's go ahead and take a look at letter C. Let's talk period, which again then will hopefully produce our B value. And if you remember correctly, well, let's see this, I guess, in action first. So we go on up, we come down. I'm seeing it from the y-intercept to there. So from there to there, that would be the period. I tried to make each of these windows horizontally, like the z-trig window. So pi over 2, pi, 3 pi over 2, and 2 pi. And so as a result, from here to here, looks to be from 0 to pi. That's where I get my full repeat. And so as a result, the period is pi. Okay. Now, hopefully you remember, and if you don't, that's all right. How do you get the B value from the period? Remember, it is 2 pi over the period. So 2 pi over pi would do the trick here. These are going to obviously cancel, and so we should get a B value of 2. Wonderful. Having answered these questions correctly, now we just go right down here, and this should be a piece of cake. So y in terms of x, of course, on the coordinate plane, dependent in terms of independent. So y equals, a is 2, goes out in front. We chose sine. B value is 2, so that's our coefficient in front of the x. C is 0, so we don't need it, so close them off and throw a -1 on the back. And that, if we're doing everything correctly, should match this graph really nicely. Let's go ahead and see real fast, and then we'll go ahead and make our couple predictions from this. I'm just going to bring this over here just for a moment, and let's type that in. So what did we say? 2 sine 2x, close it off, -1. Does it look like the graph at the right? Looks pretty good to me. Really nice. You can see the match. Okay, good. Let's go ahead and make our predictions from this. And you could do this graphically. I'm going to do it more algebraically if that's all right with you. So find y when x is 4.3. So given an input, you should be able to come up with the output. So let's go ahead and do this up here. Let's go ahead and do the calculation, and then let's check it on the graph just to see. So no big deal. Instead of 2 times x, it's 2 times 4.3. That's all. Calculator should suffice with this. All we have to do is calculate the entire right-hand side, and that would give us our y value, of course. So go back and let's just do it as a calculation. And so I have 2 times the sine of 2 times 4.3. I'm going to close it off and throw a -1 on the back. And when I do that, I get to several decimal places here. I'm going to go about 0.4688, give or take. Doesn't matter really all that much, but that's what I'll do it to. So what did I say? About 0.4688, hopefully. Sounds great. If I gave you any x, could you probably tell me what the y value is? Yeah, probably shouldn't be a problem. Now just real quick here on the graph, let's see if we can spot it. Here's pi over 2, here's pi. Remember, pi is about 3.14, give or take. 3 pi over 2 is about 4.71, give or take. So 4.3 would be pretty close, right around there. I think that's graphically where we would be looking. And does that look like a y value of approximately 0.4688? Yeah, that's pretty good. Actually, it's quite good. So you can see what we did in terms of the mathematics right here should bear out on the graph up here. Cool. Letter G. Now let's switch it. Find the first positive x value when y is -0.5. So a -0.5 y value would be right here. Obviously, there are theoretically an infinite number of x's that give me an or a y value of -0.5, but I think this is the one we're looking for right here. Now let's see what we get. Again, let's do it with the algebra. So given a y, find x. Okay. Now think about this. This seems to be kind of a 1, 2, 3, 4-step equation in order to get the variable by itself. I think we could pull off a few of these steps without too much issue. So I hope everyone would agree. If you're trying to solve for x here, the first thing you probably want to do is add 1. So let's bring that over to the other side, and you add 1, and you get 0.5. Not bad. 1 down. 3 to go. Next step, if I asked you to solve for this, probably want to undo the multiplication of 2. Probably want to divide by 2. So 0.5 divided by 2, let's go with 0.25. All right, 2 down, 2 to go. Now I think the next thing we have to do is undo this sign right here. In order to get this variable by itself, this has to go. Well, what is the opposite operation of the sine function? Inverse sine. So we have that. We're able to pull this off. We're able to undo the sign by doing inverse sine on this side, inverse sine on that side. So we're going to do the inverse sine of 0.25. That'll get rid of this. And then, guys, the last step, of course, to get x by itself, then we divide by 2. So if it's okay with you, I'm going to go ahead and do both those on the calculator. Inverse sine, divide by 2. So when I do that, here we go. So hit your inverse on that sign right there of 0.25, hit equals, and then divide that by 2. And there we go. So it seems we have an x value of about 0.1263, very small x value there. Again, that is only one among an infinite, but that is the answer right there. Horizontally, as we kind of come up, don't have to travel very far horizontally to hit that. And so there's your x value right there. Okay, good. So what did we say? 0.1263. I'll throw that in there as well. Onward. Example 2. Take a look at this one, if you would, for a minute or two. And again, if you choose right for letter A, we can avoid any type of C value. So what do you think? In this case, it looks like the y-intercept is at the top of the sinusoidal wave, so the max kind of goes down and then I guess would eventually come back up off our grid here. So it looks like it's going from the y-intercept maximum to maximum. As a result, hopefully now it's starting to click a little bit. I think you want the cosine function here. Okay, great. Same deal, guys. I do the midline first. So let's go ahead and track that right in between the max and min. Seems to be right here, give or take. So how does y equals -3 sound to you? Throw that in the right spot, y equals -3, which means we should get a d value of -3. Those match up perfectly. You know you're going to get a -3 on the back. Once you have the midline, pretty easy to come up with the amplitude here. Just count from here to here, and it looks like just 1 unit. So amplitude is 1. Let's throw an a value of 1 in as well. Really nice. Now this one's kind of interesting. Can look at it from a couple different perspectives. But the period on this, if I start at the y-intercept, I'm kind of seeing this as max to min. And that was the entire right-hand part of my grid. That was from 0 to 2 pi. So max to min is 2 pi. And then I guess I'm assuming min to max would be another 2 pi. So it looks like the period from my angle is going to be 4 pi. Okay. Now you could think of it from here to here. From min to min, that would be from one part of the cycle to its repeat, would be from -2 pi all the way to 2 pi. So again, I see that bearing out in a couple different ways. But ultimately, period is going to be 4 pi. So what's the b value? Again, second time here, 2 pi over the period, everyone. Hopefully that's really starting to click. 2 pi over the period. And 2 over 4, of course, when the pi's cancel out, we get 1/2. Awesome. All right, again, we've done the hard stuff. Let's put the model in place, y in terms of x. A is going to be 1, so it's 1 times cosine. B value is 2, so it's 1/2 x. No phase shift because we're starting at the max and ending at a max after the primary cycle. So C is 0, so we can close that off. -3 would work. Awesome. Let's check it out just to see. I like going side by side here. Take a look at yours just to make sure it's clicking though. And I go to my y equals. And what did we say here? Cosine 1/2 x -3. I'm going to hit graph. And notice it matches up quite well. All right. Good. Letter F. Find the first x value when y is 0. So in this case, I'm giving you the value of the dependent variable. Y is 0. Not sure if you've noticed it just yet, but here is where I would get a y value of 0. In this sinusoidal wave, as it just keeps going up and down and up and down, am I ever going to get a y value of 0? No, doesn't look it. Just even graphically, I don't think that's going to happen. There's no way. Now, I wouldn't mind, if it's okay with you, just taking a moment, watch how this bears out mathematically. Obviously, if I give you a y, the idea is you would try to find the x, so you would be doing this. And you would solve this equation. You'd get the x by itself, of course, and the first thing you'd probably want to do is add the 3 to both sides, and so you would get 3 equals cosine of 1/2 x, and you would undo cosine. Opposite operation of cosine is inverse cosine, and watch what happens when I try to inverse cosine on that 3. Ready? And notice it doesn't work. I have an error message. Very simply, there are no cosine ratios above 1, and there are no cosine ratios below -1. So very simply, this is an operation that just does not work mathematically. So, nope, can't do it. And that makes sense, as you can see from the graph. All right, example 2 taken care of. Let's see the third scenario in action. Example 3. Take a look at this one here. This one, it sort of looks like it's starting at the minimum and going to minimum. So the first one was midline, right? Midline to midline. Second scenario was max to max. So the third is min to min, from here to here. All right, well, just to get this moving along, I'm going to go ahead and tell you cosine is what we want. That will allow us to avoid any type of phase shift. But watch what happens here, and I'll tell you where to put the asterisk for this. But for right now, letter D, what is the midline? No big deal at all. Right smack in the middle, everyone draw that in there if you would, and looks like it's y equals 0. Beautiful. So we know on the back end we would have a plus 0. No big deal. All right, now the amplitude, without question, is going to be 3 units. So 1, 2, 3. Amplitude is definitely 3. That's great. But here is where we have to be careful. I don't want an A value of 3. And the question is, what do I want there? And let me just refresh your memory if we could. Just for a second, I promise I will be quick. So there's the cosine graph right here, max to max. But this seems to be a min to min situation. So how do I flip it? And there's the key word. How do I flip it so it's min to min instead of max to max? And if you remember, we've seen this once before, by making that A value negative, now notice it makes the primary cycle a min to min. And that's what we want here. So the A value has to be negative. So let's do this, guys. Put a little asterisk next to this one if you would. A value has to be -3. Wonderful. Now from here shouldn't be too terrible. Let's go ahead and get a period on this and get the B value. So I'm seeing the period from here to here. Min to min would suffice. And that seems to be only 1 tick mark on this, and which we concluded was just pi over 2. So period is pi over 2. The B value as a result would be 2 pi over that. You could do this a couple different ways, but essentially that's what I'm after. What is 2 pi divided by pi over 2? I don't know, maybe I've shown you this trick before, sometimes with working with a compound fraction like this. Make sure you see this kind of over 1, and I do what's called the outside over inside. Again, just a little quick algebraic trick. So 2 pi times 2 would be 4 pi. 1 times pi would be pi. So outside over inside. And you notice the pi's will cancel there, of course, and you get 4. So I don't care how you pull it off, but basically that calculation does give us a B value of 4. And we can get our model from this in a pretty straightforward fashion. So just be careful. Amplitude was 3, but we want what we would call a flipped cosine. You'll hear me use that phrase, flipped cosine. So -3 cosine, 4x, C is 0, D is 0. I think we've got a winner. Let's go check it and get some conclusions in place, and then we could do our last example, that good application on the back. So let me move this over just so we can slide and see side by side. Clear that out, guys. What did we come up here with here? -3 cosine 4x. Ooh, it would help if I had the cosine in there. Okay, and 4x. And there you go. Matches up pretty well. Good deal. All righty. So seeing these three scenarios, and we'll summarize in just a second. So we've got max to max, min to min, and midline to midline. So just numerically, because seeing these on the graph really wasn't a big deal, but if we can't see it so straightforward on the graph, there are a couple ways to calculate the midline and amplitude. So let's go get those in there. The midline is really the average of the max and the min, right in between the max and the min. So in each case, quite frankly, even though we didn't necessarily do it explicitly, we did it intuitively. Max plus the min, divide by 2. Please keep this one in mind if you would, as you'll need that piece. And then this one as well. If you can't count from midline to the max or midline to the min and get that amplitude, there is a way to calculate it using just really the max and the min. So the amplitude is really half the distance between the maximum and the minimum. And distance going straight up and down really just means we're subtracting numbers. So it's really the max minus the min. That would be the entire distance, and the amplitude is half of that, so we divide by 2. So please keep those two in mind. They're really not bad calculations, obviously, if we don't have the graph where it's so straightforward. Great. Let's put our conclusions in play from the three scenarios there. And then as mentioned, let's just do our last application. All right, so I guess what we saw, example 1 would be the first situation that we're going to look at here. And it was the one where we were midline to midline. So the conclusion we drew essentially is use the sine function if the beginning value, and by beginning value what I mean is the y-intercept. So if the y-intercept is at the midline. Okay, great. That's what we saw with example 1, conclusion drawn. Now the other two scenarios will fall under this category right here. What we found is we should be using the cosine function if the beginning value, and again, just from what we saw, what that means for us is the y-intercept is at the maximum. And if it's at the maximum, what we determine is our a value is positive. So that was example 2, by the way, just in case you're checking. Or if it was at the minimum, and if it goes minimum to minimum, then what we determine in it is a is negative. Sort of the flipped cosine, that's what this one is. So I don't know if you want to write this in here, you can, or disregard, but essentially that's what we would call a flipped cosine. See that a lot in some good applications. All right, again, put this in here if you want, if not, no big deal. But those are the three. If the beginning value is not at the midline or the max or the min, then without question it does require a phase shift. For pre-calc, that's actually what the day 2 lesson will be. All right, let's go ahead and do our last piece. So the application we'll do today will be based on tides. So let me just read the blurb here and then we'll go forward. So unlike a 24-hour solar day, a lunar day lasts 24 hours and 50 minutes. This occurs because the moon revolves around the Earth in the same direction that the Earth is rotating on its axis. Therefore, it takes the Earth an extra 50 minutes to catch up, so to speak, to the moon. Since the Earth rotates through 2 tidal bulges every lunar day, we experience 2 high tides and 2 low tides every 24 hours and 50 minutes. So this is essentially 2 periods, 2 cycles. As a result, there is a relationship between the tidal cycle and the lunar day. High tides occur 12 hours and 25 minutes apart. If you would, guys, that's your cycle. High to high, or max to max. That's your period right there. Taking 6 hours and 12.5 minutes for the water at the shore to go from high to low. So this obviously would be half the period, 6 hours and 12.5 minutes. And so if that's high to low, and then another 6 hours and 12.5 minutes to go to low to high, and hence you get your period of 12 hours, 25 minutes. That's what we'll use. So let's go give it a try. Example 4. On a particular sunny summer day at a dock along the coast, high tide occurs at 7 a.m. and low tide occurs at 1:12 p.m. I guess according to the scenario it would be like 1:12 and 30 seconds, but whatever, it's fine. High tide reaches a height of 3.2 feet and low tide reaches a height of 2.5 feet. We're going to graph first. That's the key with this. Then we write the function. If you notice, for examples 1, 2, and 3, it was pretty straightforward to write the function when we had the graph in front of us. And that's what we want to do here, everybody. So looking at this scenario, I would have a tough time coming up with all the necessary information to write my function. But if I see it graphically, it shouldn't be a problem. So let's go for it. So height in terms of time, and this will be in hours after 7 a.m. So let's go ahead and do something like this, give or take. So we've got our t and our h of t. And not too bad here. And let's see, we've got the heights going from 2.5 feet, so low at 2.5, high at 3.2, and the tides are just going to cycle between those two values. All right, that looks great. 7 a.m. will be when we start the stopwatch, and very simply, the period will be 12 hours and 25 minutes. Now, I don't want to use it as 25 minutes there, so what I'm going to do just very quickly is do the 12 hours. Now, obviously, I don't need that here, but I'm going to do just 25 divided by 60 to kind of get that period as a decimal. Does everyone kind of see that? So this is how many hours the period would be, about 12.4167, so to speak. Okay, good. So that's what I need us to write right here. So we're going to go 12.4167. That's our period. Half of it would kind of be right there. That would be the 6 hours and 12.5 minutes. Might use that just a little bit. Let's see, we're going from high tide to high tide, I see. So it's 7 a.m. It does say the high tide occurs. So let's get that going. So we're going to start here at the high tide. And again, after 12 hours and 25 minutes, the cycle is over. So high tide to high tide there, which means, of course, what we said in the explanation above, low tide is right in between. So just graphically, looks like that right there. All right, not too bad. Now again, seeing it allows us to do a couple good things with this. So first and foremost, what I would personally come up with is the midline right in between there. So if we can't count it out, don't have necessarily a grid to go ahead and pull that off, let's do the calculation from above. I think that's good. So midline, let's see, we've got 3.2 plus 2.5, and then divide by 2. So 2.85. So let's go ahead and do a couple things with this. I think I do want to write those calculations out on the board here so you can do it on your paper. So midline, let's go ahead and do this as 3.2 plus 2.5, divide that by 2, and I think I saw that as 2.85. I'm going to go with it there. Hopefully that was the case. And the amplitude, so there's 2.85. Sorry, I got off track for a sec. So there's your 2.85 right there. Amplitude, again, we can kind of do a couple different calculations, but basically let me go with what I summarized above, sort of half the distance between the max and the min. So that's what we would be looking at. How far is it from here to here? Well, it's half the distance from here to here. Well, let's go for it. So if I want the amplitude, 3.2 minus 2.5, and take that and divide by 2. And so the amplitude should be 0.35. All right, good. See how it's all coming together? So from here to here is 0.35. Now we just have to think intuitively about this, and we can write our function. Let's go to letter B. I'm going to ask you to pause for a second and give it a try. See if you've been kind of paying attention the whole way through. Be great if you could. Can you write the function based on what you see above? Okay, well, either you pulled it off or not, but at this stage, I think I'm ready to write it. So it looks like we're going max to max. So what that means is I'm going to use a positive a value. Amplitude is 0.35, so 0.35. Max to max, everybody. That's cosine. So normal cosine, 0.35 cosine there. Sounds good. Now the b value is going to be 2 pi over the period. If you want to go ahead and get a decimal on this, might not be a terrible idea, but that is essentially what the b value is, whatever 2 pi divided by 12.4167 is, times the independent variable, which is t, and then plus 2.85. Awesome. There is your model. Wow, that looks really good. I might come back and graph this at the very end just to make sure everything is okay. But for right now, let's kind of wrap it on up with C and D. Given t, you can find h of t. Given h of t, you can find t. So let's do part C. Find the height at noon. And, you know, if we're starting our model at 7 o'clock, and our model is the number of hours, or t is the number of hours since 7 o'clock, then it looks like t is going to be 5. So somewhere in here, give or take. And let's go ahead and put this in. So h of 5, essentially. We're going to let the calculator do all the work on this, but let's at least write in what we need. So 2 pi 12.4167 times 5 plus 2.85. We might get this number here on the calculator just to see it first and then go with it. But really, again, given an input, should never have too many issues with coming up with an output. All right, I do want that value there. What was that b value? So 2 pi divided by 12.4167, give or take. So about 0.5060. So that's sort of what I'm after there. Okay, well, let's do it. So we wanted to put in 5 for t. So 0.35 cosine. Our b value is this guy right here, 0.5060, times the t value. There it is, just following right along here, everybody. Close it, and then add 2.85. And there we go. About 2.56, give or take. So let's put that in. H of 5 is about 2.56. So time and height. Wonderful. Let's do the last piece. When will the tide first be at 3 feet? So that seems to be, I don't know, right here, give or take on the graph, whatever that x value is right there. Let's see if I can fit this in. So I think I'm going to come right over here. Hopefully I'll have a little room to pull this off. So the height is 3. Let's make it happen. 0.35 cosine. I'm going to get that as the 0.5060 now. Not that it matters a ton. All right, guys, what would be the steps you would use to solve that equation? I see 4 steps. Number 1, subtract 2.85. Number 2, divide by 0.35. Number 3, inverse cosine. Get rid of that cosine right there. And number 4, divide by 0.5060. Let's do all 4 together. So let me bring this over just so I have a good look on this. So here we go, guys. I'm going to take the 3 minus the 2.85. Beautiful. Now I'm going to take that and divide by the 0.35. Please do it with me on the calculator as you go through the process here. Super. So got rid of that, got rid of that. Now I've got to undo cosine. So inverse cosine. Here's the big step right here. Inverse cosine of our answer, and we get that right there. 3 down, 1 to go. I'm left with the 0.5060 times t. How do I undo multiplication? Division. So let's divide by 0.5060, and we've got it. So after about 2.229 hours, that's when it hits 3 feet. Cool. All right, so let's see. What did we say there about I missed it, 2.229. That's what I thought. Okay. And just putting units on, I'll put a little feet on that just while I'm thinking about it. All right, guys, this looks great. Good modeling with these sinusoidal functions. Hopefully it's all starting to click for you. Please let me know if you have any questions on any of the 4 examples we saw or any of the conclusions that we drew. Thanks.